Well, thank you everyone for coming. My name's Kathleen Gent. I'm on the program committee of the Community Senior Center, and we are sponsoring today's talk, which is Climate Change and Impacts on Vulnerable People and Places, with Dr. Leslie Ann Dupnay-Giroux from UVM, who is a professor of geography and geosciences and is the Vermont state climatologist. So she will discuss climate change in Vermont and explore how climate change is impacting vulnerable people and places, such as indigenous peoples, overburdened communities, and diverse language speakers. And this is a very timely and important topic for us in many parts of Vermont, including Richmond. So thank you all for coming, and we will begin. And if people have questions, is your preference to wait until you finish, or however you want to proceed is fine?
It's fine, yeah.
Thank you so much for coming today.
No problem. So, oh good. I was wondering if everybody was going to be able to hear me because I have a really low voice, and sometimes that sort of lulls people a little bit. So, you know where I'm going with this, right? So, now that the sun's coming in, it's wonderful to sort of like keep everybody awake and on their toes and all that good stuff. So great to be here. Thanks to the committee for the invitation to come and talk a little bit about climate change in Vermont and what this means for peoples of Vermont, what this means for our land, our landscape, and so on. And I always like to start with a picture. So I was flying back in, I forget from where now, a couple months ago, and took this shot. So this is the Otter Creek. And when you look at it, you see how dry the landscape is? All the browns that you're seeing on there. And you see as the Otter Creek comes in, you see all that sediment, it's emptying into the lake. So part of what we're thinking and learning and talking about with climate change is flooding is important to understand and work through, but we're also thinking about the opposite of flooding, which is drought conditions, because those are also still affecting us. So as Kathleen says, we're going to talk a little bit about all of these elements of our peoples, our land, cultures, infrastructure, all of the above, as we think about trying to become a little bit more resilient. So please don't stare at the slide because I know what you're looking at and it's not the title. So as we're looking at this and putting this into context, we had the flooding that took place in 2023 and then almost the same date in 2024. And as you're looking at this here, as it sort of plays on through, so this is from June of this year, as you're looking at this, you're seeing the storm systems, right, as they're moving, but you're also seeing, I'm gonna wait for it, do you see how some storms look like they're sitting along the ridges or in the valleys, okay? And if you look really closely, you'll see that north-south of how the storms are. And that's important for us to understand because it's one of the reasons why we as Vermonters are so susceptible because of what our land looks like, right? So this is a great example for us to kind of see visually why storms kind of line up the way they do. So that's this year. If we go back last year, we had a similar sort of situation with, this is a radar map, so it shows you how much rain is falling, and you're seeing that sort of just parked over Vermont. I'll show you the satellite image in a sec. But because we have that north-south, the greens run north to south, it's not surprising that the heaviest rain, so it goes greens to oranges to purple, so purple is the heaviest rain, right? And you see those heaviest totals are along the spine of the Green Mountains, okay? And if we look at what caused that, this is the event that was taking place last year. Yeah, I heard some wow, right? Because you're starting to see, you probably figured out that the whiter the colors, the taller the clouds, the more rain's actually falling. And you're also seeing that, you see it didn't go anywhere, right? It just sort of spun in place for a couple of days, particularly over the central part of the state. You see this, folks? Right? And so if we're trying to understand why we had that massive amount of flooding in central Vermont, like Montpelier and Barrie and the surrounding regions, look at where those are here with that nice little bullseye that just kept raining and raining and raining, okay? Now, if you have eagle eyes, you will also see, once you've kind of focused in on that storm system here, look at what this is showing you on the back end. Do you see anything happening? This is 1:30 in the afternoon, right? So I'm trying to make sure that you're all with me here. Yeah. So are you seeing anything happening on this western side in here as it kind of plays out? Are you seeing any change in color? Like around now. See this? See that? You know what that is? It's the wildfires. The wildfires that we had going on last year, just before we had all of that flooding, right? And so what I'm trying to have us think about is why we have to know about the various things that are affecting us so that we don't get this whiplash, right? You don't go from, oh my goodness me, it's drought, oh my goodness me, it's wildfires, oh my goodness me, it's floods, because some of these can be going on at the same time. And that's one of the ways that you try to be resilient, by knowing that some of these are actually going on, not just consecutively, but at the same time itself, right? So remember we were about the wildfires last year? Well, this is showing us that a week after that massive set of floods, the wildfire smoke was still there. So I bring that up because we need to know about the messages coming out from the various agencies and why it might seem like we're going from one to the next, okay? So if I had to ask you, this is the audience participation time, because you've been way too quiet, and it's only been 5 minutes. But what else do you think Vermont is susceptible to apart from floods and wildfires? What else do you think we...
Well, now tornadoes.
Now everybody's going to start talk, all right?
Tornadoes are coming.
Tornadoes, yes, we have tornadoes, particularly in the valleys. What else?
Freezing.
Freezing?
Yeah.
Did you say freezing?
Yes.
Absolutely.
Blizzards?
Blizzards for sure.
Ice storms.
Ice storms. Okay, this side of the room's winning.
Ice jams.
Pardon?
Ice jams.
Ice jams for sure. Couple more to keep up with this side. Anything else? Drought, absolutely.
Heat waves.
Heat waves, you're doing well. One more?
So increased invasives and diseases.
The species and the diseases that they bring, so vector-borne diseases, absolutely. And I'm sorry, I cut somebody off on this side. No, we're good? One more?
Variation,
Variation.
which is much greater than it used to be.
Yep, so increased variability, which makes it challenging to keep track of all these things because their characteristics are changing, okay? So that was an awesome list. And let's see, did we get practically everything on there? Wind is one thing that we don't always think about, right? You know, like winds that come downslope and are really, really fast, okay? Those are what we call Shirkshires, really, really fast downsloping winds on some parts of the greens. And that goes to the microclimates that we experience. And then the other piece, yes, we did get the insects and the disease. We got those. And what else did we miss in here? Thunderstorms, right? Thunderstorms is the other piece, but we got a pretty good list, right? So if we think about that and we think about putting these into context, these are some slides from my colleagues at the National Weather Service, and what they have done is they've gone back through time and looked at some of the most significant weather events across the state. So going all the way back through to 1927, which was a flood of record, still is a flood of record for the northern part of the state, right? In the southern part of the state, the new flood of record is Irene. Yeah. So going all the way back to 1927, and we have Irene, we have a couple other hurricane events. So this is to give us a sense that hurricanes, tropical storms hitting Vermont is not something that only just started, right? Going all the way back to see what are some of the ways in which they have affected the state and its economy over time are some of these things in here. So we got ice storms and ice jams. We got some of those across in here as well, okay? So it sort of makes you think, why is Vermont so hazard prone, okay? What is it about the state that makes us so prone to both wintertime, summertime, fall, in fact, all seasons? What is it about the state that makes us so prone? And part of the answer has to do with where we're located. So we are in the northeast of the entire US, northeast of the continent, which means we can get stuff coming from all these different places and hitting us, right? So that's one part of it. So if I use this map here, we can get stuff from the southern parts of Canada, we can get stuff from the plains, we can get stuff coming up the Atlantic coast. That's one reason. But another big reason is that Green Mountain piece that we just looked at here. So most of our valleys and rivers run like this, okay? So the Green Mountains here, which in addition to the White Mountains in New Hampshire, are all part of the Appalachians, okay? So anything that comes at us is gonna have to rise because the mountains cause it to rise, right? And every time air rises, you're going to get more rainfall or snowfall coming from it. So that's a lot of what we had to think about. So with this in mind, and looking back at the system in 2023, do you see how the influence of the Green Mountains is so prominent here in helping to see why we had a lot of precipitation sort of focused in here? So if I blow up that map that I showed you before, I know you still can't see those numbers, right? But you can see the colors, and so we're looking at where some of those highest values were across in here, okay? So that system was very, very different from what we saw in Irene, which was more focused on the southern part of the state, so Quechee, and other places around that region. And so as we look at that and looking to see what are some of the impacts of that tremendous amount of rain in 2011, some of the unfortunate impacts are losses, whether it's from a personal property, whether it's from a road infrastructure, and these are some shots from the intervale where every time floodwaters touch crops, you know you have to dispose of them because there may be contaminants in the waters themselves, right? So we'll come back and talk about that in a sec. And if you look at Irene and why it was such a major impact in the southern part of the state, it's because of how it moved. So the red line here shows you the track of Irene, okay? And as you're looking at it, you're seeing that Irene sort of came up along the western side of the state. Do you see where the state is? State boundary? Okay, let me run my fingers here. So there's Lake Champlain, all right? So there's a border, a Canadian border, and if you look closely here, there's the outline of the state. Got it? It's sort of creamish color here. Does everybody see this? Yes. All right. So when Irene made landfall in Jersey and continued moving up, the Hudson Champlain Valley, so the western side of the state, then it actually moved from the western side of Vermont here to the eastern side, to the Connecticut Valley. Do you see this, folks? Okay. And a lot of that movement from West Valley region to East Valley region was taking place across the southern part of the state here. I don't know if you've ever driven in southern Vermont. Lots of complex topography down there, right? And when a storm system has to go over that, you're going to have a lot of raining out going. Every time it goes up, every time it comes down, right? And so you're seeing how long it took to actually go from the Hudson Champlain Valley across to the Connecticut Valley. And then once it was in the Connecticut Valley, then it just accelerated up into parts of eastern Canada, right? So that staying there kind of like poured itself out in that region, okay? Make sense? Okay, so knowing that gives us these fresh eyes to go back through records that show you hurricanes that have moved through all the way back to the 1800s. We have that ability to actually look at storms and where they moved. So we can go all the way back and see what other storms that did similar things to Irene. So for example, 1938, okay? Tropical storm Hurricane Floyd in 1999. And then, of course, here's Irene here. And I'm gonna ask, do you remember Floyd? Do you remember hearing that name at all? Awesome. And Floyd was huge because Floyd actually produced more rain on top of Mount Mansfield than Irene or even last year did. Floyd produced 14 inches of rain. Yes, that's almost twice as much as what we got. But you know why Floyd didn't create a stitch of flooding? It's because we were in a drought that had lasted for 18 months. And so what Floyd's rains were doing is soaking into the soil, right? Because you had been dry for 18 months. That's over a year. And so when these large systems make landfall, you have to ask yourself, did it rain last week? If it did, it's going to flood. If it didn't rain last week or last month or last year, probably a lower chance of it flooding, right? And that's why we have to keep in mind what it is we're in the middle of or what was going on just before, right? So we're looking at that, and just in case you are curious, this is a way of seeing all of those storm systems that have passed through close to us and what happens next. So you've got some of the major ones in here, including the ones in the 1950s, like Carol and Edna and so on. And then some of the others that, again, you may or may not remember, like Bob and Floyd, and where those kind of moved in here. So this gives us a sense of the fact that the Northeast, where we live, is not free from hurricanes, okay? So that's the takeaway here. So I'm going to kind of show you how all of this comes together. And I know you can't read anything on that map, right? It's okay if you say yes. Do you see some colors, some reds and yellows?
Yes.
Yep. Do you see some reds, yellows, and greens in here? Okay. What those are the roads that were affected during Irene. And what this map is the map that was created in 1927 to show where the roads that were affected. Now, a lot of roads are still in the same place as they were because there's a reason, right, of where you put the roads back in time. They haven't shifted for 200 years. And so I'm going to zoom in a little bit so you can see this a little bit better. So here's the central part of the state in here. And the roads that were affected in 1927, same roads affected in 2011, same roads affected 2023, and so on, right? So this gives us a heads up for where we're going to have problems because those roads are, in some cases, literally, I kid you not. Here's a river, here's a road. Yeah, you've seen those, okay? And so that gives you a sense of where those vulnerabilities will continue to exist. Okay, so there's a historical, cultural piece that kind of goes along with that. So let's talk about vulnerability a little bit. And when we're looking at vulnerability, if I say vulnerability to you, what do you think of automatically?
You're more likely to get it.
You're more likely to get it, right? And anything else that kind of pops to mind, more likely to get it? Any places, peoples kind of pop to mind? Note wasn't a title, but anything that's...
Don't have the resources to necessarily deal with what's coming.
Absolutely. So maybe not have resources to deal with what's coming. That's a critical source of vulnerability. So when we think about vulnerability, I'm going to credit one of my colleagues in the Geography and Geosciences department, Dr. Sherry Morse, who this is her research. And so what she's done is she's put together the various ways that we can think about vulnerability. So if you're not able to evacuate, okay, if you speak a language that is not the same as what the information or the alert was put out in. All of these are ways that we can think about why some folks might be more vulnerable than others, okay? So if we look at that, we can kind of break it down into a number of different pieces. So we can do this from like just the land outside. So as you drive around Richmond, can you think of places that you're like, oh, yep, probably going to get hit by this or that. Think about some of those places. So there's a where, like a geographic piece to this. So where is vulnerable, and so that's one way of looking at it. And part of that has to do with, like, I just remember we said at Vermont where it is because it can get hit from all. So that's geographic, right? We can also think about this from whether you are close to a river or not, so that riverine piece in here. But then if we kind of think even broader than Vermont or the Northeast, we can think about nations that are island states. So I grew up in Trinidad, and if you think about it, when a hurricane's coming or if a major system's coming, you've got one of two options for evacuation. You either, if it's big enough, you either have to wait for a ship to pull up next to the island to evacuate folks, or you airlift folks out, right? So island nations and island states have different types of vulnerability and what that means for the peoples who live there, okay? So we're looking at how this plays out for us. So that's a where. How about the who? And when you think about the who, here are some of the things that we just looked at. So if we speak different languages, making sure languages are accessible to everyone so that information gets out for all folks. If we are differently abled, do we need to make sure that if we have an evacuation taking place, can everybody have full access to the evacuation potential? And the one that sort of stuck with me, well, two actually, particularly because of COVID and the way in which COVID sort of affected us from a mental health perspective, all right? That was one piece that's critically important. But then the other piece that sort of really, really stuck with me in the last few years is if you are unhoused, you also have a particular vulnerability. So that came to the fore in COVID when there were all these heat waves, right? We had heat waves as one of these sources of hazard. And you heard messaging that says, there's a heat wave today, shelter in place. Don't go outside or go to a cooling center. And my automatic thought was, if you don't have a home, how can you shelter in place, right? And so that's a different sort of vulnerability as we're thinking about this from an equity perspective, all right? So we had where, landscape-wise, land-wise, we have who, and we can also think about what is also vulnerable. So the infrastructure, right? Whether they are road infrastructure, whether it's critical infrastructure is one piece in here. But then we also think about our grid. And we don't always think about that in Vermont, right? If it gets so hot that the wires start to melt, right? That's another critical source that we're looking at in here. So if we look at some of these pieces, excuse me, if we look at some of these pieces, these are to jog our memory for, you know, along Route 100, there are a number of places where the rivers and the road next, like almost directly next to each other. And then on the left-hand side here, this is the town of Waterbury, where I-89 is running along here. You've got the Winooski in here, and during Irene, it got pinched off at these 2 points here. See this? Okay? And so it was sort of isolated for a while because when the Winooski jumped its banks, it actually sort of crossed all of these in here. Okay? So we're looking at that, keeping that in mind, because I'm going to have us do a little bit of a detour. Does everybody know where the Intervale is? Okay, so the Intervale is in Burlington along the Winooski, and one of the challenges is that it floods whenever we have, you know, a lot of water moving down the Winooski. And I was giving a talk there in August of this year, and I had never actually walked the Intervale. Right? So I did a Google map to actually see where I was going to be giving my talk. And I never realized that the Garden of Supply was actually on the Winooski here, right? So I was giving the talk at the Intervale Center in here. And seeing what that land looks like when you're actually on it, very different than looking at it on just a Google map, all right? So one of the reasons why I'm showing you this is one of my colleagues, Judy Dow, is an Abenaki scholar and elder. And we were doing this program at Shelburne Farms a couple weeks before that, where we were kind of interplaying between the Abenaki ways of knowing and knowledges with Western science and how they could be braided. And so in the Abenaki tradition, there are all these stories about the Intervale and that you visit there, but you don't live there. And when I was doing all of the sort of like, how does the Winooski flow relative to all of this? Do you know the falls by Winooski, in Winooski, where there's, you know, there are all these wonderful shops and restaurants on either side, where the mills used to be? There's actually stories in the Abenaki tradition of going from one side here to the other before there were falls. And so just knowing some of the things that we can learn from all of these ways of knowing is important because it helps us to understand the land a little bit better. So if you look at this, I'm going to help you see where the Winooski is. You see the Winooski here running along, right? Did we see this? Right? If I stand back here, I can tell places where the Winooski has flooded in the past. If you look really closely, you'll see places like here. See that? Where the water actually flooded in the past, and it's now like a little tiny lake. All right, so here's one. We call that an oxbow lake. And if I zoom out a little bit more, you can probably tell me more places where the Winooski has flooded in the past or where it's gone in the past. You see what I'm trying to do here? Okay, so places like here, see this? Right? Places like here, following my fingers, which is why we want the flood, we want the rivers to access their whole floodplain, because we can see on maps like this, on images like this, where it's gone in the past, right? And that's part of the reason why in the Abenaki ways of knowing, you visit the intervale, but you don't live there, okay? Because they've known about some of these things. So that brings us to the question of things that are changing, including our climate, which is why you came today, right? So we're thinking about changing climate and what does that mean for Vermont. So part of trying to set this up is to talk a little bit about what's called the Vermont Climate Action Plan. Heard about the Vermont, the one that was done at the state level? I was just talking, I forget your name now. Virginia was telling me about the local climate action plan here in Richmond. Would love to hear more about that at some point, maybe after a little bit. Because one of the things that we did at the state level is the Vermont Climate Council was stood up, and part of the outcomes was to produce this Vermont Climate Action Plan, which was adopted in 2021. All right? And it was my privilege to actually help spearhead the writing of climate change in Vermont. And one of my colleagues, Dr. Jason Schaefer, actually created this diagram to help show from a visual perspective how climate is projected to change in Vermont and how confident we are about those projections. So those of you who put your hand up and said, yes, or I've seen or heard about the Vermont Climate Action Plan, if I come back, I want that to be everybody, because you would have gone and taken a look at it, because it's got some really, really rich stuff in there that might sort of inform what you're thinking about here in Richmond itself. So what you're seeing here are some of those hazards, the ones that we all sort of identified, and whether we think they're going to increase as we go through time in the future, and how confident we are of whether it's going to increase or decrease. Right? So this is how confident we are on this part here, and then this is, you see most of them are going to be increasing, right? And stuff like snowfall and extreme cold going to decrease, right? Does this diagram speak to you? It's clear, right? Helpful? All right, so I'll tell Jay that. So this is one way of trying to look at all of these moving pieces, all these moving hazards in here. So who and what and where are going to be affected by these things as they change. And so if I had to look at it, infrastructure, all types of infrastructure, not just roads, but also health infrastructure, right? If you think about heat waves, for example, emergency management, and when we talk about stuff like human health, it's not only water, it's also air quality. It's also whether you got bitten by a tick in a part of the state that you would never have expected to be bitten by. So all of these things are important for us as we kind of step on through forestry, tourism, agriculture, all part of this. And part of why we are looking at which sectors are vulnerable is because you probably already know this, but it's good to kind of just do a quick refresher. All of this weather, climate, and climate change is really local. The impacts are really, really local. So we can be in one county, and part of the county is really dry, part of the county is really wet, right? Because of how the storms have moved through. So this is a quick example here. I was giving a talk in Fairleigh, and Fairleigh was in part of Orange County that was actually bone dry. Drive a few miles north, and they're actually wet. So green is wet and yellows are dry. So that could be like really, really important for us to understand as we try and do our municipal plans and so on. So most people, when they hear climate change, they think about water or temperature, okay? We can expand that to air quality and humidity and so on, but when we think about all of these temperature and water pieces in here, I'm going to start at the bottom. What we're seeing is when it rains or when it snows, there's more falling from the sky, right? So heavier rain, more snow. Does that make sense? You've seen this, right? Okay, so we're seeing more of this, more moisture coming from the sky as our temperatures warm. And what we're seeing fewer of is those little light drizzle type stuff, so there's fewer of those. The other thing that we're seeing is more heat waves, right? And fewer of these bone-chilling cold that we would have seen 20, 30, 40, 50, 60 years ago. So when a huge rain or snowfall event takes place, then it's not surprising to us why we see these large values. So again, greens are usually low values and reds and purples are high values. So you're seeing the bullseye, so Mansfield, Jay, Killington, kind of popping out because those are the highest mountains along the spine of the Green Mountains, okay? So that's on the heavy rainfall, heavy snowfall side. Now, I think you brought up drought, which is critically important because we can also be exposed to drought conditions. So how do you know you're in a drought? The grass doesn't grow. What else?
Lakes and rivers drop.
Yep, the lakes and, absolutely, lakes and rivers drop. So you see that. Anything else? By the way, that's 2, 0.
Wells go dry.
The wells run dry, okay.
Not more algae.
Say that.
More algae and
Oh, more algae on the lake surfaces. Yeah, absolutely. So all of these things we see when it's dry. And so the last time I tried to use this example, it bombed because I was in a different part of the state that folks have not been to St. Albans. Let me try this here. Do you know that there's a nice little park in St. Albans, just outside on the lake itself? Lovely little park benches. Okay. Not going to bomb this time. All right, so back in 2016, that severe drought that we had in 2016, we were able to actually see that as you were walking along or picnicking or walking your dog, because how the water had actually receded into the lake was enough for you to see where it's supposed to or used to be wet, right? So that's one thing that you can actually see on the land as you're kind of walking around. So that's one indicator. So if I go back and I try to see, is Vermont prone to drought? What you're looking at here are all of these oranges and yellows and browns show you when Vermont was in a drought, and all of the greens and teals and blues show you when Vermont was really, really wet, okay? And this goes back to 1895 to the present. So if I were giving this talk 60 or 80 years ago, I wouldn't be talking about flooding. I'd be talking about all of these droughts that Vermont was susceptible to. See that? Okay. And then around the early 1970s, we had a shift in the climate so that we are now getting more precipitation or more wet times than dry, but the dry have not gone away. Okay. So we're still susceptible to droughts, but not as much as we were back in the 1910s or so. Yep. Okay. Are you surprised by that?
What's the D4, the D3?
So these labels along here, what this is coming from something called the U.S. Drought Monitor, and it's a way of categorizing how severe the drought is every single week. So today is Thursday. The one for this week was released this morning. Yep, so if you're curious, just look up U.S. Drought Monitor Vermont, and you'll see exactly where we are right now across the entire state. So this brown color here is the most severe. So if I was showing you California, you'd see a lot of this brown, right? Because their severe drought, this exceptional drought has gone on for years.
And right now, we're pretty good in the drought. We've done all the burning permits and stuff. I mean,
You mean like right now, as of today? I couldn't ask for a better question. I will show you where we are, like in the last little bit here, because do you think we're dry right now?
yeah.
Yep. Yeah, so there's a geographic difference going on, yes. So all of this, I like to use Lake Champlain as a way of showing how this goes together. Do you know where the Echo Center is? Right? So right outside the Echo, there's a little rain gauge and a water gauge that they track how high the lake is every single day. And they've been doing this going back to at least the 1800s. So when doing that, what you can do is you can plot how high the lake is today, how high it's ever been, and how low it's ever been, right? So when you do that, what you get is one of these charts where the top line here shows you how high Lake Champlain has ever been. This bottom line here shows you how low it's ever been. The red line in the middle shows you the average or the median, which means there's only one line left, and that's for that year. Is everybody still with me? Okay, so this is 1909, and you see back in 1909 was when the lake was the lowest it's ever been. And we're in the Richmond Free Library. If you are able to go back and look at any pictures from the 1900s, like early 1900s, you may see some black and white pictures of folks in petticoats going out and literally walking on the stones in Lake Champlain because of how low it was. Okay, so that's here, and 1909 was when we set some of those records. Here is 1927. Do you see we were dry? You see that? And then we got 200% of rain in 2 days, and that's when we flooded. Okay? The 1960s was a dry decade, and so shouldn't surprise us why we're down in here, right? And then 2011, here is Irene. Okay, so Irene caused so much flooding along Lake Champlain that we set all of these brand new records here, right? But we can also think back to the flooding in the spring of that year, right? When all of this snow melted like that and caused brand new records here too. Yep, okay. So I know you know where I'm going with this. So I asked you if it's been dry, and everybody pretty much said yes. Okay, does that confirm it? So here is this was as of last week. Today is going to be pretty much the same if you go back and look at it. You see, we're now below the average line, right? And going towards, this lowest line here. So that sort of reinforces what your perception is, that yes, we are dry, okay? Even though we had floods this year in June and July, notice they did not create a brand new peak, okay? And we've continued to dry out over the course of the last few months. Okay, so how about last year? So last year, we had the floods in July there, set some brand new peaks, and it continued to rain, even as we had the wildfires, set some more peaks, and then remember, just as the year was ending, we had some more flooding, okay? So the point of all of this is that it can flood practically any time in the year. This is not just a summer thing, it's not a winter thing. We can flood any time of the year if the conditions are right, all right? So that's one thing that we're keeping in mind. Now, tell me if you've ever seen this. It's May or even June, and there's snow. Have you seen that around here? Okay, if you do, please send me your pictures, because my picture's a little bit old, all right? And every time I give a talk, it's the same old pictures, so it would be nice to kind of refresh them. So if you see this in the next few months, where you've got, your rhododendrons and your other blooms out, and it's snowing on them, and it's like Mother's Day or later, please send me those pictures. Okay, and tell me where you got them, because that would be awesome to actually kind of keep a track, because we've been seeing this, right? And that's called a backward spring, because it's going in the opposite direction of what spring's supposed to do. Spring's supposed to be continuing to warm and getting into liquid, like rain as opposed to snow. And so when we see that, that's called a backward spring, okay?
What about lilacs in the fall, like November?
Like they're still blooming?
Yes, I saw lilacs in
Oh my
November
goodness.
last year in Vermont.
That's another way that things are going in the opposite direction. Did you take any pictures of them? Oh, you just saw them. Wow. Wow.
My little lilacs, well, I got big lilacs, but all on the top, there's sprouts of things and little lilacs up there. So
Oh my
instead of
goodness.
the big lilac, it's
Yep.
probably
Yeah, just at the top of
just, yeah,
So not at the ground level,
not at the ground.
just at the top.
Yeah, so it's like
Huh.
the warm weather just thought it was spring again and
Mm-hmm.
started sprouting, and
Interesting.
so it'll be interesting how it will do next year.
Exactly, because that's the same thing that, you know, researchers who are botanists look at with red pine that wakes up in the middle in January. If you have a thaw, it wakes up and it starts to photosynthesize, and then when the cold comes back, then they shut down, and then you see those brown needles in the springtime. You've seen those, right? Yeah, so if you know where you saw some of those lilacs, can you let me know so I can pass that on to folks who study lilacs so they can, you know, maybe take a closer look at that. Or your daughter. Awesome. So speaking of all these seasons, the season that's changing the most is actually winter. And as you look at this, so again, this is my colleague, Dr. Jason Schaefer, who put this together. And what we're looking at here are the warmest winters at the airports of Burlington. And you see a lot of the most recent years are in here, but also years back in the past, all right? And I think you had said variability. Who said variability or variations? Yes, you did. Yep, so that's what we call climate variability. So as a climatologist, we talk about climate variability and change. Right? So what you were picking up on is this sort of fluctuations that you're still seeing in here. So we're looking at all of the states and counties that have the highest or the warmest records on the books. Okay, so going back to 1895 or so. So that notion of going between warm and cold, that variability, we saw that a couple winters ago, where just on the course of a week, we went from being warm to being cold, right? And part of this has to do with where is the cold air coming from? And it's coming from further north of us, the Arctic. So if I play this for you, what you're gonna see is, as this video kind of plays, you'll see every time the blue dips down, it's gonna bring cold air with it, right? And then as the reds or the oranges go up, it's going to bring warm air with it. And I'll play it one more time. And as you're looking at it this time, look at the dates down here, okay? As we're playing this, what you're noticing, there's December, so it's going day by day through December, and you're seeing where the cold air is seeping south, and then, so we just passed, there's Christmas here, and then we're seeing that warm air coming up. And if you remember back in time, remember how some of those cold snaps and snow were observed in parts of Texas? Okay, and they don't have I think somebody said at the beginning, resources to sort of deal with this, so that's a vulnerability that they have to start thinking about preparing for, okay?
A lot of power failures.
Power failures, absolutely. So that's why we have the grid as one of those pieces that are susceptible, because it's not just the heat, it's also the cold, okay? So this is something that's come up, and for me, this was something new because I hadn't heard about this idea of a climate haven before the floods of 2023. So people started asking me about it, and I said, what is that, and where are you getting it from? So they started sending me all the websites and the newspaper clippings and so on, and as we think about it, and as we know, every place has some sort of hazard, right? And so if every place has some sort of hazard, there was actually a National Academies webinar about housing in particular and the disasters that can affect housing, okay? And so the two scientists who were talking were asked this notion of our climate hazard at the very end. One of them said, you can try and engineer against all these hazards, and the other scientist said there's no such thing as a climate haven, right? Because he then went on to give the story of a lady who was in Florida who wanted to leave where all the hurricanes were being hit, moved to Oregon, and encountered wildfires there, moved to Vermont, and was flooded. So that stuck and resonates for me as this notion of every place has something that you need to know about and to prepare for, right? So this idea of a climate haven, interesting concept. And This one here brought it even more home. So Deke Arndt is one of my dear friends and colleagues who is the director of the National Centers for Environmental Information. That is the body of NOAA that collects all of the weather and climate records going all the way back to 1895, okay? So really important center. Located in Buncombe County in the town of Asheville. Okay? And all of the folks, like my friend Deke, when the floods were coming in Asheville, everybody sort of chipped in to go to the building to preserve the records. Because these are the records not just for the nation, but also for a lot of the world. So these records are precious and dear, because this is how you know how things are changing over time. And so instead of helping out at home, a lot of folks were actually helping to protect our nation's records. So when we talk about Asheville as a climate haven and knowing that it can be affected as well is really something that sort of strikes really, really close to home. So let's end a little bit on a slightly different note, which is how you build resilience, knowing that all of these things are going on. And so as we're doing this, and this is probably part of the conversations going on here, like, does the planning committee actually meet here in the library or next door in the town offices? Okay, so in the general region here, right? Some of these things that you're talking about and thinking about probably have to do with mitigation, adaptation, and building resilience. And so part of the other hats that I wear is being involved with the National Climate Assessment. And so this is straight out of the 5th National Climate Assessment that was released in November of 2023, where they go into, do you know there's more than one type of resilience? There's community resilience, there's land resilience, there's all of this. So as a planning committee, it's really thinking about what type of resilience are we trying to build. And your other resource in this is the Climate Action Plan that was adopted in 2021, because there are a number of priorities and strategies in there. Have you read it cover to cover? Not yet, but you probably will, okay? Go back and see what some of those strategies are in there so that you can actually kind of, get a jump start. Don't have to create things from scratch. So as part of that, and part of that writing of climate change in Vermont, what I did is I did a lot of deep listening to all the conversations, and I created this diagram, which is in the Climate Action Plan. And what I try to do is to figure out, if you're trying to build adaptation resilience, how do you do it in a way that you know what it is we're trying to plan for, how is our climate about to change or could change, and what are the things that we need to keep in mind. So our governance is important, right? Whether it's county level, town level, and so on. Right? It's also important to look at what our grid's doing, where are our roads, and so on. So we've got all that infrastructure pieces in here. There are places that probably should not be developed, and so thinking about climate resilience zones. And then this interplay between our natural lands and our working lands is also something that we're looking at in here. Okay? So I call this my do no harm diagram, because I'm trying to center this in an equity-based frame. Okay, so all peoples, all ways of knowing. And as we go through, if there's gaps in our information, gaps in our understanding, how do we identify those so that we can actually try and do something about it? Okay? A lot in that diagram, right? So go back and take a look at it in the Climate Action Plan. So here are some thoughts for you, and this is where I know some folks are actually scribbling down already, and some folks are reflective observers, so you're keeping us all up here. So some things to kind of keep in mind, just throwing these out for you, okay? How do you, as you're going through and doing your planning, how do you kind of work with what you've got in your landscape, whether it's your wetlands, or whether you've got natural lands or working lands, forests, and so on, and how do you, are there places here, let me ask this as a question, have places in Richmond actually flooded or been affected? Okay. And are there parts of the land that you can maybe think about doing things differently on? That's a question. I'm just posing that as a question. Okay. So Mike Klein, who headed up the Rivers program at the Department of Environmental Conservation for years, really is an advocate of trying to make sure that rivers can flow where they have flown in the past and have access to that floodplain so that you don't always have your road infrastructure being affected. Other resources are the National Climate Assessment, the Northeast chapter, because I was privileged to lead this writing of the fourth National Climate Assessment, Northeast thinking in here. And so some of these things have not changed. We're still susceptible to not just moisture increases, but also thinking about humidity and so on. So this is another resource for you to go back and look at if you would like to delve into what's going on in Northeast, including Vermont. And if you're taking an all people's approach, okay, if we're trying to do that, this for me is critical. Whether I am writing a grant or whether I am working with a group for the first time, I have to make sure that all peoples are involved right from the beginning, okay? Because there's nothing worse than inviting folks after the fact, right? We try to make this as inclusive and as equitable as possible. So these are some of the things to kind of keep in mind. Are there folks moving into the town of Richmond? Okay, what about the tax base? What about the land base? All those things are critically important in here for us to sort of have as part of our conversations. And in addition to the round church, what else is Richmond known for from an economic perspective?
Cochrane ski area?
The what?
Cochrane's ski area?
Cochrane ski area, okay. And are there potential changes in the way that the snow might be made? Okay, so thinking about this a little bit globally as you try to bring this down to the local planning piece is one thing to kind of really, really dig into. So I'm going to leave you with some work that my students did with the town of Underhill 2 falls ago. And if you've seen this already, my apologies. If you're seeing this for the first time, feel free to ask questions. So the Climate Change Task Force in the town of Underhill asked our class if they could help with the rewriting of their local hazard mitigation plan and to bring in elements of climate change into their local plan, okay? So I think we had about 20 students worked for the entire fall semester in thinking about some of this, using all the resources that I've shown you before. And what they were trying to do is to figure out exactly what else can they put in that hazard mitigation plan in addition to flooding, all right? So this was a semester-long project. It involved a lot of whiteboard stuff, you know, brainstorming, looking at all the hazards in Underhill, looking at all the peoples who live in Underhill, trying to figure out what needs to be in that plan. This is a very messy process, as you can see. Well, not my handwriting, but it's a very messy process because there's no clear end to all of this. And the students were challenged to take all of the 4 years of their knowledge and actually apply it to answering these questions. They did an awesome job. The final report was about 80-something pages long, and a lot of it had to do with, have you thought about geology? Have you thought about which road might fail? Have you thought about this wetland here? Have you thought about where everybody lives? Who lives a particular drive that you don't know how to get access to, and what happens if that road is washed out? All of the little pieces that need to be in place to actually improve the plan. So people always ask me, how is Underhill using our work? And one of the biggest things that came out of it is, have you heard the term Geographic Information Systems, or GIS? Oh yeah? Okay. So for Underhill, having stuff in a GIS format was really important because then you can zoom in and zoom out. Look at which road is like exactly how many feet apart from the water source, right? So having that GIS format was really important. And thinking about geology, thinking about landslides, thinking about where droughts might occur, but also, because Underhill is in a valley, thinking about air quality concerns, right? So these are some of the things that were brand new to using the information to kind of improve the ways in which it could be, that mitigation plan could be enhanced. So bringing this all home, okay, because we covered a lot today. Are you super saturated? Get the joke? Super sat? Yeah. Okay, 2 people got the joke, that's fine. So thinking about all of these things here, one of the things that I always love to stress is this has to be holistic. It has to be a total system. Otherwise, somebody or something or some part of the land or even the town or the city might get left behind. So thinking about this from a systems perspective, and as we're doing that, focusing on all of the hazards that are changing right now, that could be changing, walking with everybody from a knowledge perspective, from a ways of knowing perspective, because there's a lot of stuff going on out there, right? And sometimes you feel like you're being battered and hammered. If it's this, then it's that, then it's the other. So I always ask this question, okay? Are you feeling tired right now? Feeling stressed a little bit? Okay? So there's tired. And then when we were on COVID, there was COVID tired. And then you've got climate change tired. Right? So all of these, and sort of honoring where everybody is as we try and walk softly is one thing in here, because for me, as we try to build resilience everywhere, I have complete confidence in us as a species and what we're trying to do and trying to keep moving ahead. So with that, folks, I thank you for the invitation to come and chit-chat a little bit. And I have a request for you. If anybody is interested in collecting how much it rains in your backyard or anywhere else, sending that into the National Weather Service. You do this already? Awesome. So sending this into the National Weather Service, because there's some counties or some parts of counties where we've got some gaps. And so trying to fill those gaps, okay? So this is called the COCORAS program. If you want to know a little bit more, or if you are already doing this and want to send your records in and know they will be used and much appreciated, come ask me about this, or please send me an email. So Kathleen's standing here, so that means it's time to do some Q&A.
Thank you. Excellent presentation, and I know I learned a lot and really causing me to think much more about what we need to do in Richmond. One type of event that we've had, in addition to the flooding of the Winooski River, is these microbursts where parts of our town can get hammered, primarily rain, but also wind,
Right.
which Underhill has experienced as well.
Absolutely.
So I did want to just mention that. And do people have any comments or questions? And if you'll bear with me, I'll bring you a mic so that MMCTV can.
So my question is, with all the fires going on in the west, do they affect our temperatures and our weather here in the east? I mean, I know particulates are coming across. You can see that on the clouds and all. But does it make a big difference with the weather on the East Coast?
So that's an awesome question, and the answer is probably yes and no. I'll tell you why. Because of where we are, the fires that are most concentrated, the smoke that's most concentrated from those fires are going to be along like southern Quebec, Nova Scotia, New Brunswick, if they come down towards us, simply from a proximity, because as smoke moves out, it tends to actually disperse like that. So the closer you are to where it happened, the more concentrated it is, the bigger the impact on human health and visibility and potential aviation, right? So that's part of it. At the same time, we also get forest fires locally, but those effects are probably more contained because we don't have as huge a fire regime as they do in the West, but it doesn't mean we have to stop thinking about them locally. We do. We do need to look at fires locally, right? And then your question goes to forest fires in the West, and why I said yes and no is if the forest fire is large enough and severe enough that the plume gets transported high enough to get onto those high-level jet stream type of winds, then there is a potential for that to move and affect us further downstream. Exactly.
Jet streams,
Exactly.
especially from Canada coming down.
Right.
Circulating.
So as we're looking at this, and this is why I love satellite images, you can actually use satellite images to see, are you getting this stuff, or are you getting the stuff closer to the ground? Because both are equally important from a respiratory perspective, right? So the finer particles are the ones that are going to stay higher, and the larger ones are going to be the ones that stay close to the ground will affect you.
Good to see you again.
Likewise.
It's great. First of all, another source I'm not sure you mentioned that I found very useful is the UVM Climate Measurement Center. And if you Google that, you'll get a whole raft of information about Vermont and this area in particular. But my question stems from the onslaught against science that pervades many arenas, of which this is one. What would you use as arguments to convince the non-climate believers that they're wrong? What arguments would you use to try to buttress the problem?
So for me, as a climatologist and climate scientist, it goes back to the data. And it goes back to not just the data themselves, but also the provenance of the data. And how the data were collected and the metadata around that, and therefore the reliability and the vetting of those. I actually had an example of that come up in the Climate Action Plan, the writing of it. And because these things are so meticulously documented at all levels, from the putting in of the station, the collection of it, the checking for errors, and then how is it being used and how is it being interpolated, all of those steps are very well documented, and they're also in the published literature. So that means other subject matter experts looked at it, and if there was a flaw in that, it would have had to have gone back through the review. Otherwise, it wouldn't have gotten through. So when somebody asked me about how do you know that we have all these stations and all of these data and records and so on, I was able to go back through to all of these original documented ways of sort of asserting the provenance and say that's how we know, right? And so using that, because it has to be accurate, right? It has to be accurate. And you have to know what went on. So even if the station in Richmond went from like the railroad tracks to somewhere else, you have to be able to say that. You have to be able to say the date it occurred and whether the person doing the observations changed. You have to be able to actually account for all of that. And that's how you build credibility, because there's nothing under the carpet, right? You're going for complete transparency. So it's an awesome question, and like I said, I've lived it. And that's how I approach it, right? Mm-hmm.
We know that to keep from experiencing the worst effects of climate change, we need a very lot of rapid action in reducing carbon emission, greenhouse gas emissions. And with our recent election, I have some real concerns about us not being able to make those rapid changes as much with the new president coming in. And I'm wondering what your thoughts are about that.
So I think the best way of answering that is to think that, or to remember that action happens at multiple levels, right? And the local level is critically important, the regional level is critically important, and for me, thinking back to however many years or decades, that is what kept a lot of the forward momentum. That there was action and thinking going on at the various levels, right? So whether it is a single group, or whether it's one town or municipality, whether it's like one part of like a regional planning commission, all of those are pulling together to actually continue the process of either trying to mitigate against or helping all peoples to adapt to our changing climate. So that's why there's a diagram that I show in other talks that shows how much progress has been made in both adaptation and mitigation, and we're not in the same place as we were in 2014 or 2018, right? So that's the piece that we need to continue doing, and a lot of it is at the local level.
So I just have a quick comment that is a little bit related to Bob's question. And I'm not sure that it applies to Vermont as much as some other places. But one thing that I think you should have on your Who's Vulnerable slide by your colleague, I think, is to add misinformation, the susceptibility to misinformation. It's been shown to be a huge impediment. You know, if you don't believe or you're getting the incorrect information about the flood that's coming, for instance, you're not going to do anything. And I think in recent disasters across the country, not here so much, that has been a problem. That has been a big problem. So beyond your scope, because it has to do with the media and, you know, a whole bunch of other pieces of the landscape, I feel in Vermont we're a little less susceptible to all the misinformation and the lack of trust in science and the lack of trust in data and the feeling that data is irrelevant. You know, those are kind of broader social trends that are happening. But I think it ought to be on your slide about who's vulnerable. So
Absolutely, and that's a point that's really well taken. And I'm going to add a tweak on your tweak. In addition to misinformation, the timing at which information is disseminated and received, and I'm thinking about it literally from like a flood warning or a tornado warning. If it doesn't get out fast enough, or if it gets out at a time of day when folks are not awake, then you've got a very, very different response, right? And so, yeah, it's this whole information delivery, reception piece that's also part of that too, yeah.
I was just wondering if you had a percentage of what you, or with your data, of what you feel is human cause and natural cause.
Off the top of my head, no, I don't,
No.
sorry. Yeah,
I mean, you know,
but
it's,
can you email me?
I will. Thank you.
Okay. Just as the sun's going behind a cloud. Oh, Bob has one more question.
Actually, a clarification. I'm aware of quite a bit of literature which says by far the most prominent cause is human intervention. If you look at the world studies and things like that, it's quite definitely true. There is, of course, this wobble, this variation, which occurs over many, many millennia. But this is an unusual situation where I think the evidence is persuasive that it is humans that are causing it. For example, the rise in CO2, which has occurred before with volcanoes and things like this, but that's not the case this time. It's us.
Right. And then the other piece, too, to go back to your variability comment, is we're actually learning more every day about the unknown unknowns, which are, I guess, more challenging than the known unknowns, because it's stuff that you didn't know that you didn't know. And as a scientist, it keeps me on my toes, right? Because I literally have to be trying to keep track of every new study that came out that links to something else that you didn't know it was linked to. And I think that's the challenge. I mean, I was giving a talk in Montpelier yesterday, and it's one of the things that I try to, I use the example of medicine, right? You know, you go to the doctor, and he says, well, you know, it might be this, it might be that, and let's run some tests. And if we think about it similarly in the whole natural systems piece, there are things that we have modeled well and we know well, but there are other things that are changing that we didn't know were going to change, right? And the two examples that I can show you for this year is, remember it was supposed to be a really active hurricane year? And then it got quiet and then it reactivated. That's something that you would not have expected. So folks like my colleague Phil Klotzbach at Colorado State are probably delving into that, because he is like one of the most leading hurricane experts, and it even baffled him, right? So there are parts of the system that are chaotic and stochastic that are pieces that we didn't even know were going to change. And so the same flexibility that we accord when the doctor tells you, let's try this, let's try that, I think is the same flexibility a climatologist or somebody working in this field would also appreciate, because we're trying to also keep up with some of these changes as they're taking place in real time.
This is kind of an unusual question, but it's something I'm curious to know about. You're a UVM professor, and there were a lot of things on that list
Too
that
many.
you've done. And you're the state climatologist. How does the state climatologist fit into the organizational structure of Vermont government? And what are your responsibilities? Are you a paid employee of the state? What agency do you come under? I'm just kind of curious to
Okay.
how this fits in state government and what kind of responsibilities go with the job of Vermont climatologist.
Okay, that is an awesome question. So, state climatologist as a position actually date back to at least the 1950s, when they were federal state climatologists who provided all of the outreach and the service and the understanding to peoples around the entire nation. The program, the state climatologist program, the federal program, ended in the early 1970s. And so there were no state climatologists anymore. And then it got transferred from the federal government to states. And it was up to the states to decide where that position was going to sit. For some states, it sits as a direct report to the governor. Other states, it's in an agency like natural resources or agriculture. And in one case, it's actually written in the state code that the person in the agriculture department shall be the state climatologist. I would say for about 80% of us, we are faculty at land grant or institutions that have that service function. So UVM, so it's University of Vermont and State Agricultural College, right? So that's the lineage of it. And so for my position, there is a memorandum of agreement between NOAA, so the National Oceanic and Atmospheric Administration, and the University of Vermont, that the person who is in the faculty position in the Department of Geography, in the line that teaches climatology, is the state climatologist, right? So first and foremost, I'm a faculty member, and state climatologist roles are part of what we call service. So teaching, research, and service. So I don't have an office in Montpelier. So, people think, oh, you're blah, blah, blah. No. So first and foremost, it's faculty at UVM. And then I work really, really closely with my state of Vermont colleagues on things like the Climate Action Plan or cross-agency activities and so on, if that helps. So, yes, very, very interesting. And now it's on record.
So, thank you again, Professor Dupinay-Giroux. And I suppose if folks want to stay and chat, but I think we really appreciate you being here, and Mount Mansfield Cable TV for being here, and all of you. So thank you.
Thank you.